Hello, you data savvy people, and welcome to Engaging Data Bytes. My name is Simon, and today I'm joined by John Scott from VoltSpeed. Hello, John. How are you?
Great, Simon. How are you doing today?
Not too bad, thank you very much. And John, we're here today to talk about is Kimball dead? Is Kimball valid still? But before we go in and unpick that little conundrum, let's just recap on what we know about Kimball. So Kimball's a very popular data modeling technique used in data warehousing, and it's focusing on the importance of business processes to create dimensional models. The very best data models keep end users' perspective around the data from front to center to back, and it keeps them engaged with their data based around how they're interacting with it and their business process. If you use Kimball, the chances are you've probably built dimensional data marts, and you've built it for specific areas around specific data processes. And it helps you then derive measures and KPIs that the users understand, and they can make and interact with their data in a very easy and simple way. Overall, Kimball aims to create actionable insights, and well-designed data models helps users enjoy that in popular tools, visualization tools such as Power BI and everything like that. On today's agenda, we're going to discuss how Kimball copes with change in a data warehouse, how it copes with performance and scalability issues and SLAs you might have to consider when you're working with Kimball models and processing data, storage issues and rates of change in data. So let's start off with our little test case. So we're going to talk through a business that sells cars. Okay, so here we have a short, small data model where you can see we have a date dimension, we have an invoice dimension, we've got a customer dimension. The thing we're going to focus on today is the product dimension. So the small business at the moment has a retail shop and they sell cars, so their product dimension is really just filled up with a description of a car. Now, let's just say that this data model's been up for 6 months. Everyone's using it very successfully. They're finding out lots of insights. But now the business has changed. Now the business has grown to the point where they could bring on additional or buy an additional business. And that additional business has got motorcycles, electric bikes and bicycles as part of their product range that our business didn't have yesterday. So overnight, we have these additional products that we need to bring in and somehow add to our existing data model. There could be an added complication as well. If we have these different product types, some being motor, some being non-motor, there might be an extra category that we need to incorporate within our product description to denote whether it is a motor vehicle or not a motor vehicle. In addition to the acquisition of an additional business, the owners have decided that to implement a new inventory management system. And this is to help them categorize their motor and their non-motor vehicles. And it's a separate standalone system from their sales system. This merger has helped them restructure into a divisional type business where they have different divisions handling different products. So the change overall, the two types of changes that I'm sure people will be familiar with. You're either familiar with the mergers and acquisition based business and there's new stuff coming in. More often than not, it will be an introduction of a new system. Either one of those changes will have you thinking about, okay, what do I need to do in this case? And I kind of like to think about these four problems in two sort of stages. The first stage is before we make any changes whatsoever. What do I need to refactor? What am I going to have to do to the model? Can I just add the data straight in? Does my data fit? Is it the right granularity? Will my KPIs work the same way? Do I need new KPIs? Has the business model changed? Is the processing changes? I really need to drive into what the business want to get from this from the very outset. And then I need to sort of spend some time understanding what data I might lose. So do I need to throw away that type 2 dimension that's got all the historical change of my product? Or do I need to somehow bring that in and turn it into something slightly different? How do I save the historical data? Or am I okay just to blow it away and start again? And what's the implications of that? What is the implications to the business? How are we going to handle if that historical data has disappeared? So you can see there's potentially additional activities to to go through that might increase the amount of time that it will take me to develop or redevelop the data model. And this all impacts the business. And once I'm making the change, how much support do I need from the business? How much time am I going to take away from them if I need to bring down the data model so they can refactor the visualizations and the reporting on the end of it? There is a lot to consider in this type of change. This is the problem we're dealing with, and I've just spoken through how what I'd start thinking through as a Kimball, purely doing it on a Kimball basis. John, how would you handle this sort of change?
Yeah, well, I think Data Vault can help. So in terms of how can we refactor without breaking anything? Well, the Data Vault architecture, as we'll see, is actually designed for change. Changes in Data Vault are normally additive and localized, which reduces the risk of breaking existing work. Will we lose any historical data? Well, it's actually one of the key benefits of building a Data Vault, because a Data Vault keeps an auditable history of all the loaded data that we've ever loaded, even while the Data Vault is changing. Will there be any impact to the business? Well, because the changes to the Data Vault model can be deployed safely, existing reports can continue to operate while we bring in new changes, test them, get them approved, etc. And we can transition to them when the business is ready. And how fast can we make these changes? Well, Data Vault modeling uses simple and repeatable patterns which lend themselves to automation. And Vault Speed is a Data Vault automation tool that allows teams to move fast.
How can we build a data vault for this business?
So to build a Data Vault for the business, we want to start with understanding how the business sees itself. So this is a business that sells motor vehicles and non-motor vehicles to customers in shops. We want to understand the business concepts. So they're things like products, customers, shops, invoices, and their inventory. And what are the business processes? We want to identify how the business concepts participate in each process. For example, a sale of a product always involves a customer and a shop. And once we've done that business analysis, let me introduce you to a few of the Data Vault concepts. So from the business concepts, we're going to identify what we call business keys. These are keys that just have a meaning to the business. Then we go looking for the source tables that match the business concepts that we've come up with, and we model those into hubs. The attributes of those tables, they end up in satellites, which are the objects that store the history in the Data Vault. And for the relationships that we found in the business processes, they become links in our Data Vault. So let's have a look at a simple example. So we've got a business process here of a sale of a product involving a customer and a shop. And as you can see, our hubs represent those business concepts, customers, products, and shops. Are linked together with the link object here. And then you'll see each of the hubs have a satellite which stores the data and historizes it. And there's also a satellite off the link as well that records the details of the sale. So once we're done modeling our business concepts and processes, then we'll end up with a finished Data Vault model that looks something like this. Yeah, so what I want to show you now is the product hub here. So let's zoom in and have a look at that. So if we look at our product hub here, you can see we have a satellite for each of the tables in our source systems that relate to products. And this is what we call source integration in Data Vault.
So what I'm seeing here is going back to our problems. If we started off with a simple hub for the products and a satellite to describe the passenger cars, then we would, as new products came on board, we would just add additional satellites to describe the bicycles, the electric bikes, the motor vehicles, rather than having to rebuild the whole lot.
So there's lots of benefits to modeling this way. Storage benefits that we'll get to a little bit later. And it also lets us load in parallel, which talks to the scalability benefits of Data Vault as well.
So where does Kimball fit into Data Vault? I've got all these Power BI dashboards and things like that that will use a Kimball dimensional model, and I just don't understand how to get from the Data Vault bit to Kimball.
Yeah, well, let's have a look and see what we've got so far. So far we've been talking about modeling the data vault. That's all happening here in the raw vault. And here in our information mart is where we want our dimensional models. So you can see this business vault in the middle with transforms of our data from the raw vault into the information mart layer. And this is what you can do with Vault Speed. Design your dimensional models with one big benefit being, as you change your raw vault, maybe adding more sources around those existing business concepts, you can just regenerate those dimensional models and they will include those new sources for you.
That sounds really interesting, John. Can you show us how that works?
So let's see Vault Speed in action now. So I've loaded source metadata into Vault Speed. Let's have a look at our sales source. We have all the tables loaded here, and the way that we model those business concepts is in this visual modeler here. So let's have a look at how we see motorcycle purchases. So you can see I've identified the business keys for each of these source tables, and these lines, we drag and drop those to create the relationships. So this is showing us that we have shops, customers, and motorcycles as products participating in this one. So let's have a little preview of what that part of the data vault is going to look like. And you can see we have our shop hub. This is the link that represents the sale, linking the shop, motorcycle, and the customers. So another consideration for loading our source data is where it's going to be loaded into. I've already mentioned the satellites, that's where the attributes are, but we might want to split something like customer data into a separate satellite for GDPR purposes. So that's what we're doing here, creating a satellite split. You can use the same technique for splitting up tables with different rates of change. And it's a good technique for managing the storage of data in your data vault. So once we're done with modeling all our sources, it's time to create our data vault. And you can see here, we're integrating those individually modeled product tables into our hub products. So let's have a look at the result. Again, once we're done doing that for all of them, we'll have the final data vault model that we showed earlier. Okay, so now that we're done building our raw vault, let's switch to the business vault and see how we can build our dimensional model. So I'm on a screen here that lets me tag my satellite attributes, in this case, to participate in a dimension. And then using the Vault Speed templating language, we have here a template for building a slowly changing dimension. The important thing to realize about this template is it's not just for building a single dimension, but for building a dimension off any hub. And this template's used to generate the SQL. Here's an example here. We've got a customer dimension, and you can see here keyed off our business key with a date and all the attributes. So we're done building our data vault and the dimensional models in our business vault. So how do we deploy? So the DDL ETL generation screen, we can choose our target database and generate the code for building and transforming the data in our warehouse. In this case, I've chosen Snowflake, so this will generate SQL for deploying and transforming the data in Snowflake. To our automatic deployment screen, so you'll see the list of all the code generations that we've done. And from here, we can deploy directly or deploy to Git, for example, to kick off a deployment in a CI/CD pipeline. And that's it. That's how you build a data vault and deploy using Vault Speed.
Excellent. Thank you for that demo, John. I guess that's kind of answered quite a lot of our questions as far as, how we could technically overcome some of these issues that we would ordinarily bump into using Kimball. And I think you've demonstrated the fact that the data vault as a methodology kind of can help you get straight to doing the modeling and step over the problems that you get often with a pure Kimball model, where you have to refactor, redesign, consider how you're bringing the data in. It's a lot more straightforward. I guess it takes us on to the next challenge, really, and the next challenge is more around like the performance. And I know you touched on it when you were going through the example, but yeah, in a Kimball model, when you add things, and quite often people will just add stuff on top of stuff, and you end up with lots of processes. You can end up with either a complexity issue that sort of slows the compute up and means that you can't process everything by 9 o'clock. Or you could have the other issue where you start off with a Kimball design that works in the early days, maybe the early months, but scale becomes a problem. As more data comes in, it becomes more and more complex to process. How does Data Vault get around those sorts of issues?
Yeah, so if we go back to where we zoomed in on our product hub here, so I hinted at some of the benefits of this architecture, but let's talk about a few more. So a couple of points to address the scalability issue. So I already mentioned that data can load in parallel, and you can kind of see from this architecture why, right? There's no dependencies between these satellites. They can all happily be loaded at the same time. And Data Vault employs a really efficient way of loading using hash diffs, which means as source data is presented, it can very quickly tell what data has changed and just load those changes.
Do you want to talk about how Vault Speed manages or processes jobs do you want to show how it might actually orchestrate data processing?
Yeah, sure, Simon. So the orchestration in Vault Speed actually happens with external tools. So you can use Airflow or Azure Data Factory, Matillion. We also support what we call generic FMC that lets you use your own orchestrator as well. So in the flow management control section, you would create the orchestration definitions, or DAGs, directed acyclic graph, and generate the code for that, just like we did with the ETL and DDL generation before. So I've got an example here of creating a DAG in Snowflake using Snowflake tasks. And you can see here, this is the orchestration for loading one source. And as we move from left to right, you can see it starts and then it splits, and we're loading our hubs, links and satellites for our individual objects concurrently. And this shows that you can, or how we support loading data in parallel. So this helps you scale tremendously as you add more and more data sources. Okay, so in summary, we've looked at some of the big issues with a Kimball model data warehouse, like things breaking due to refactoring, data loss issues, performance issues. So by introducing a data vault as the foundation for our data warehouse, we now have an auditable historical record that will stick around while we continue to change and improve the warehouse. We've unlocked productivity amongst our team due to Data Vault's simple modeling patterns that support automation. And we've addressed performance issues by choosing the Data Vault model, which won't buckle under the strain of the warehouse growing in size and volume.
So I think Kimball is definitely dead if you're using that approach to build your data foundation layer. Now, don't get me wrong, I still think Kimball is very much needed as the consumption layer for your dashboards and for your reports. Remember that Kimball starts with the business problem or the business event, and then maps backwards into your entities. Whereas I think in my career, I would have loved to have turned up to a data warehouse to see the business described as entities, and then to start building business process reports and business event reports around that. I do think that if you want to have a more sustainable and resilient data warehouse, you need to be using Data Vault as a methodology. It's just going to save you a ton of refactoring and change that you will experience as part of the Kimball methodology if you're using that for your foundation. And what I like is VaultSpeed will help you automate all of that, so you can do your build, you can do your deployment. As John mentioned, you can use the templates to build the standard pattern, and you can automate your Kimball models straight off of the raw vault. And who doesn't want that? Who doesn't want to save time? So with that, I'd like to thank you, John, for your time today. It's been a pleasure going through this with you.
Thanks, Simon.
And we're now open for questions. The first one's come through from Carl. I think this is going to be a good one for you, John. How does conformity work within data vaults?
We need conformed dimensions in our dimensional models, like across our sources. And, you might remember me zooming in on the product hub there. Just simply the fact that we are creating this model, integrating those sources around those common business concepts, and in that example, the product, you just get your conformed dimensions as a consequence. So there is no extra work you need to do in that case. So if you're, creating a dimension around one of those business concepts, you'll get the conformity just from doing the data vault modeling. That goes for adding additional sources, down the road. So, most people work on their data vault in an iterative way. Just implement a few business concepts at a time, and then come back to later ones. So, as you're adding more, you'll just get that conformity, as a consequence of that modeling.
I just want to let everyone know that it's no surprise that that engaging data absolutely live and breathe data vault. It's the methodology of choice because of the, as I mentioned earlier on, sustainability and reliability you get from the design pattern. And we've worked with VaultSpeed to come up with a package to help prove this out for companies who are tempted but haven't quite got there, or they've got a project where they think Data Vault could help, or that maybe they have come up against the problems we've described and they're looking for a better way of doing things, maybe to re-engineer their data warehouse. So our package comes with a 2-month VaultSpeed license with a combination of engaging data help. And in that, it's really designed to prove out all of the concepts we've spoken about here and get you up and running with, maybe a little bit of delivery built in, so you can prove out this stuff works and deliver value back to the business. And so I'd like to thank everyone again for turning up. Thank you again, John, for sharing your insights around Data Vault and VaultSpeed. And we'll wrap up the session. Thank you very much.